Once we have the Automata simulation complete, with all of our cams installed and our proper motion being generated by the tangent relationships, the next step is to take a look at creating a motion study for our Automata simulation. This can be done by moving to the Assemble panel and then clicking on Motion Study. Here it's going to ask for select the joints to animate. From our browser, we'll have to expand the joints folder and find Revolute 9, which is the joint that we will use to animate the model. From here, the selected joint will then ask us to select the curve to add animation points. As we go along with various points, we can click on the curve and set to various angles as well as what steps we wish to have the particular angle be achieved at. So by clicking, you're able to see a preview here on step 6. We're going to be moving to 45 degrees. If I move to step 20, I click to add another point, and I can move to 90 degrees. Pressing enter or clicking off in the graph area will also go through and allow this to happen. If I do not want these points, I can go back and select and click the minus sign that comes up from the contextual menu. Here in the activity, we're going to go ahead and take those points off. For activity 4.1.7, they want us to create a motion graph that shows 3 rotations of our crank handle. So moving back to point number 1, you cannot place a point at step 0, but you can at number 1. We're going to place an angle at 0 degrees, which is going to be the starting position. At the very end, we can go ahead and set at step 100. We can go ahead and put in 360 degrees. You're going to see the line tends to go at a straight diagonal. Pressing play allows us to see the motion and as it goes back and forth. The mode depends on play once. We can play forward and backward, or we can play a loop. We can also adjust the speed setting by moving the slider. Adjusting the slider and pressing play allows to see the speed that goes back and forth. Again, moving backward and forward allows for the motion to continuously move back and forth through the steps. Playing on a loop will give an accurate look to see how it would be to continuously turn the crank handle in one direction. Adjusting the speed allows us to see how fast we are moving through the various steps. So moving too high will cause this to happen, and you can see how fast the line is moving. I'm going to back this back down to where we're able to kind of visually see this, but I'm going to go ahead and hit pause. And here I will click on the last point. To get 3 rotations, 360 times 3 would give us 1080 degrees total. Now I can go ahead and hit play, and on the loop we can see how much faster that this turns as we cycle through those different degrees. I'm going to back the speed back down to get a little bit more of an accurate look at how our automata is functioning. The motion study can then be used in order to create a rendering and create some options for like videos, still images, and really nice looking models to display and use for presentations. Clicking OK will accept the motion study, and now the motion study will be in the browser, and we'll collapse the joints folder, and with that we can edit the motion study if we wish. If we wish to just look at the motion here in the model in the design workspace, we can always animate the model from Revolute 9 and be able to see it. We're not able to adjust the speed or to be able to adjust how many steps or increments that this is able to process. So as we go along, in the next video we'll take a look at the rendering environment and how we're able to create a rendering of our automata simulation, as well as maybe create a video to show our motion and to be able to communicate that to potential clients.